Okay, hello everyone. First of all, thank you, Sudha, for the great presentation. Okay, we have heard lots of promising benefits of Copilot. And right now, I would like to elaborate more on the impact of generative AI on software development in the long term. And here in our study, we use different metrics to measure outcomes. And besides code activities, we also care about what other effect could be happening here. So we also take care of code quality and code popularity. So my name is Fangchen. I am a second-year PhD student in information systems at UT Austin. Today it's my great honor to present the joint work with Professor Ashish Agarwal and Professor Wharton. Our topic is the impact of generative AI on software development. So as many of you may know that generative AI is being used for all those content generation process, and AI is changing the way how information is processed and how tasks are performed. So generative AI is shaping and redefining the future of work across various industries. You see there are several AI peer programmers like GitHub Copilot, Replit Ghostwriter, and the famous ChatGPT. So in the previous presentation, Sudha has elaborated a lot on how generative AI could be applied to software development. So here, I will not spend too much time introducing those tools again. So we see there are lots of industry evidence and a growing stream of reports talking about generative AI. And there are huge interest from the industry, especially on how those AI tools can help developers, but systematic research is lacking here. And we would like to provide a systematic study using observational data to evaluate the impact of generative AI on software development. And here today, I would like to present some evidence of our current finding. So we see that some researchers, they have investigated the impact of generative AI on productivity in some non-programming related tasks. For example, some scholars, they study the impact of ChatGPT on writing tasks, and they find that ChatGPT helped reduce the writing time and increase the writing score. And in another example, exploring the impact of AI assistants to customer service, some researchers find that AI assistants can help increase productivity in the customer service context. But those studies, like the task about writing and customer service, they are well-defined and discrete tasks, and they are comparably simpler. So lots of insights here may not be applicable to software development context, because software development has some unique features, like it may require constant updates, it may need iterative development, and sometimes many people participate in the developing process for the same project. So team collaboration is also necessary. So when we talk about software development here, it's a totally different story. That's why it's necessary for us to conduct a separate analysis to see how exactly generative AI is going to influence the software development. And here we see some benefits of AI peer programmers, just like Sudha mentioned in his presentation. AI peer programmers like Copilot can help speed up the coding process for developers. However, there are also some lab experiments and surveys being done pointing out to the potential challenges of AI peer programmers. For example, developers may find it difficult to edit or debug the AI suggested code, or there might be incompatibility issues, like developers need to take extra time to integrate the suggested code to their original content. And moreover, like AI peer programmers were trained on public code that may sometimes include bugs in the source. So sometimes AI may suggest insecure patterns with bugs. And in addition, AI peer programmers may hard to combine multiple methods and find the optimized solutions for the developers. And lastly, there are also some concerns about biases. Like developers may facing anchoring bias as they excessively rely on the initial information suggested by AI, or there could be automation bias as they are inclined to favor AI's decision and disregard any contradictory information. However, those studies are limited in scope as they use experimental setup to test the short-term impact of AI peer programmers. And some of the findings are more like the anecdotal evidence, as they are trying to show the preliminary result on the code itself. To our knowledge, there's no systematic study focusing on code outcomes. Lots of study here focus on coding process, like coding speed, debugging, editing, and biases. In our study, we're going to talk about the code outcome. Like we care not only the code itself, but also code adoption by others and code quality in terms of how well Copilot, those AI peer programmers can help address issues in the code. And here I want to emphasize the big tension here between the positive and negative impact of AI peer programmers on software development. On the positive side, we see that AI peer programmers can help enhance developers' efficiency and help them accomplish more coding tasks. And developers who lack experience dealing with code issues, AI peer programmers can suggest some potential solutions and help debug the current issue. And also, software development is often a community-oriented process. Developers love to follow each other and adopt others' code. So if AI peer programmers can help generate more code with high quality, such code could be more popular and attract more attention in the developer community. However, on the negative side, so AI peer programmers may impede the coding process or hurt code quality due to all these challenges I just mentioned. And also regarding the code popularity, so when work with AI peer programmers, developers are more like working with a comprehensive dictionary with all the examples. So they don't need to follow other people or adopt other people's code. So that may hurt the online learning and knowledge sharing in the developer community, especially in the open source setup. So all those tensions leads to our research question. So let me formalize the questions here. So how does AI peer programmers affect software development outcomes? And we measure outcomes from 3 dimensions: code activities, code popularity, and code quality. So some studies, they have focused on code activities, and the previous presentation, they did very interesting experiments on code activities. But again, they are very specific tasks. It's not very clear that whether those results could be applied to other coding tasks or a broader and general setting. So it's still necessary for us to evaluate the impact on productivity. And another perspective to look at is code popularity, because in the developer community, especially in the setup of open source, people are passionate about their code. They love to share code and make sure other people follow them. So if we find code popularity or the code adoption is getting lower, that may dampen the online learning and knowledge sharing in developer community. And another perspective to investigate is code quality. So quality is automatically needed to use software for any activities. If we find code quality actually decrease, that might be a warning to use AI programmers in developers' project. In our study, we take Copilot as an example, and Copilot was made available in different integrated development environments at different points in time. And here we focus on the 3 most popular IDEs: Visual Studio Code, JetBrains, and Visual Studio. So we randomly select repositories that use each one of those IDEs for the treatment group, and we use Paulson exact matching to find corresponding control group. We use data from GitHub because it allows us to investigate the impact of Copilot on diverse coding tasks. And we do the analysis at the repository month level because repositories are important units on GitHub. They can provide some contextual information like code purpose, development history, and component interactions. And also developers, they can contribute to code development, and they can even share or review code at the repository level. So we extract data from January 2021 till the end of 2022, given that Copilot was first available in June 2021. And since each IDE had different time to support Copilot, we further divide our sample into 3 IDE groups. And here are the sample size of each of the group. And again, all repositories in our treatment group were randomly selected, so they have good representation of different kinds of repositories. So here we use a typical DID model to do the analysis. And to further evaluate the impact on code quality, we assess developers' ability to solve issue at the repository level. So we define an additional variable, the proportion of open issues that were eventually solved, by calculating the number of closed issues divided by the total number of issues. And the distribution of such a variable is bounded between 0 and 1, so we use fractional response model to evaluate this parameter. And more specifically, we use the number of create, delete, commit, and pull requests to evaluate code activities. Code popularity is assessed by the number of watchers and forks. So watchers here are developers who bookmark the repositories, and forks are a copy of repository created in other users' account. And also, code quality is evaluated by the number of newly opened issues in the DID model and the proportion of open issues that were eventually solved in fractional response model. And here are our preliminary results on code activities. We see that Copilot has positively and significantly impacted the number of create and delete activities, and this finding is consistent across all three IDEs. But it's worth noting that not all repositories have significantly increased in commit and pull request activities. That may suggest that not all repositories have a greater number of updates to their code base. And by the way, the metrics we use to test the training productivity here are different from the previous presentation. And next, about code popularity. So we see that Copilot has increased both the number of watchers and the number of folks, and also is consistent across all three IDE. So the fear that Copilot may take away people's interest in other people's code may not be evident here. So that's good news for developers. And one of the plausible reasons might be with the help of AI peer programmers, developers they can finish their coding task in a shorter time, so they have more time to pay attention to others' code, and they can learn even better. Next, here we find a mixed result on code quality. We see that the number of newly opened issues have significantly increased, but the proportion of closed issues was not significantly affected. That means developers' ability to solve issues was not significantly impeded by Copilot. And we are further investigating this impact, and we hope to provide some underlying reason in the future presentation. So based on our current preliminary result, we see that Copilot helped increase productivity at repository level, and also it has favorable impact on code popularity. So it may suggest that Copilot can facilitate online learning and knowledge sharing in developer communities, especially in the open source setup. And for code quality here, we have observed a mixed result, but we are still investigating the impact on code quality right now. So to conclude our contributions, our study is one of the first large-scale empirical study to explore the role of AI peer programmers, and we use observational data from GitHub to evaluate the impact of AI peer programmers on different software development outcomes like code activities, code quality, and code popularities. Also, our work contributes to the literature on generative AI. So lots of work has been done to explore the role of generative AI in well-defined tasks with objective evaluate measure. But right now, we are examining the role of generative AI in open-ended software development. And also, we wanted to provide some insights of AI adoptions for software development managers. All right, we are still working in progress. So for the next step, we will do more individual level analysis and to test heterogeneity. Also, we consider to use double machine learning to deal with the unobservable in the matching process. And we will do more mechanism analysis. Thank you so much, and we welcome any feedback.